going to start with the bottom. Do you see the top one is in standard form? We did that maze the other day and we worked on that, so we'll do that one too. But let's review slope-intercept form since that's fresh in our mind. Can someone tell me where should I start that line? Awesome, I heard a 3. So would you go ahead and put a 3 on your y-axis? Okay, and we're getting that from right here. Next, do you see this negative 3/4? So what should I do now? I'm going to go down 3, 1, 2, 3, to the right 4. 1, 2, 3, 4. Do you notice the that will match because my line is going down? So it looks like this. All right, let's take a look at the next one. On this one, I'm going to get a different color. You can tell the difference. On this one, we need to find the x-intercepts and the y-intercepts. So just to review, to find the x-intercept, you're going to plug 0 in for the y. So we have 3x plus 4 times 0 equals 12. Most of you at this point don't need to write that out. You just know in your head. What does that do? It cancels out that. Now we divide both sides by 3. What's 12 divided by 3? 4. So the x-intercept is 4, 0. Now let's do the y-intercept. Instead of plugging 0 in for y, this time we're going to plug 0 in for x. So this time it makes the x-coordinate cancel. We divide both sides by 4. Y equals 3. This is the ordered pair 0, 3. Would you plot those 2 points and tell me something you notice? Plot those 2 points in blue and just, you can give me if you notice something interesting. Okay, you can just let me know. Would you check with the person next to you? See if they notice the same thing. Frank, what'd you notice? Wait, what? You want me to? Ben, what did you notice? They're the same line. 0, here's 0, 3, here's 4, 0. Okay, let's go back. Does anyone remember what we called these? So this is called coincident lines. Have you heard of the word coincide? If something coincides, it goes with something else, but coincident lines means the exact same line. So do you see my blue line and my pink line? Do you see how they're going to share all of the points? Forever and ever and ever and ever and ever. How many answers is that going to be? A lot. So much that we're not going to say infinity. What this means is there are an infinite amount of solutions. You can't list them all. an infinite amount of solutions. Can't list them all. All right. We ready? Flip over. Okay, again, I give you one of each. Would you find the x-intercept on that top line for me, please? That's what I got. Sorry, it's going to auto-correct in a second. I got 4, 0. Do I need to talk about that? All right, would you find the y-intercept? We're doing this line right here. That's where that is. All right, so that's what I got for my y-intercept. Would you now plot those 2 points on your xy axis, and would you connect them with a line? Let's do the other one. So the other one is slope-intercept form. Marie, where should I start my line? On that with the second one. 2. Good. So for our second one, we're on to that one now. We're going to start the line at 2. And 1/2 means I go up 1 over 2. And Santos said, hey, these are parallel. And he's right. These are parallel lines. This is where it's real helpful when you're doing a line. Just use this like side of a paper calculator or something just to make sure. Because I obviously didn't do that. That looks kind of hurt it a little bit. But they are parallel lines, which means they're never going to intersect. What's the solution to this? There is none. No solution. No solution. Okay.
You still just did it 0 with the line there?
Yes, Ben, if you would like to do that instead, sure. Okay. So now we did 3 different examples, right? Look back on page 1. Hopefully, I noticed some of you didn't write down the first one, but we were doing it in class at the beginning of class. You did up here, I was doing it on the iPad, okay? And do you remember those lines intersected? And then the next example, what happened? They were the same line. And this one, they were parallel. Those are the only 3 things that are going to happen with a system. So that's what we're going to summarize. So let's summarize. What would parallel lines look like? Would you just draw any parallel lines? How many solutions do they have? None. Or if you want, you could do that. If you're looking at the slope, they are going to have the same slope, but different y-intercepts. Same slope, different y-intercepts. At this point, you guys don't know what substitution or elimination is because we haven't learned that. You might have learned that. But, so we're going to have to go back and fill that in once we do substitution. I think we're going to start it tomorrow. So, all right, intersecting lines. For this one, guys, would you just draw two lines that intersect? Any two lines? And for your two lines that intersect, would you kind of like circle right there? Okay, why am I circling that? Because that's the solution. How many things did I circle? One. It has one solution, and just realize it's an ordered pair. Okay, so it's not one number technically because it's an ordered pair, so it's an XY. Okay, here's the deal with intersecting lines. For sure, they have to have different slopes. They could have the same y-intercept because that could be the point where they intersect. Or they could not have the same y-intercept. It doesn't matter. The big deal is their slopes have to be different. Because if they're sloped at different angles, eventually they're going to meet. So for the y-intercept, I'm going to write y-intercepts can be the same or different. Y-intercepts can be the same or different. Okay. Last word, coincident. Coincident. I think of coincide. I don't know. Some of you looked at me funny when I said that. But if something coincides with another, it goes with another. Okay. Or sometimes we would say like a coincidence. Have you heard that word before? If something's a coincidence, like, oh, it's almost like the same thing happened, kind of. Okay, so I'm trying to make a statement that just says coincident. That word really just means the same thing. So if you want to write above there that means the same line, because that helps you, that's fine. Just draw a line. And then what I like to do for this, because it's hard to tell, is draw another line on top of it, but put the arrows in a different spot so you can really tell that it's two lines on top of each other. Okay, how many solutions? Infinite number of solutions. Some people would even say all real numbers for x. X can be any real number. The y is going to be a different value, but you're going to have an infinite number of things that are on that. And coincident, if they're the same line, what would have to be true about their slope and y-intercepts? They're the same line. So what? They're both the same. Same slope. Same y-intercept.